So I will take this privilege maybe to introduce myself a little bit. So, my name is Hoey, and I'm the co-founder and CTO of the company. And today we'd like to talk about this, how US would catch up in the battery manufacturing and lead in the next generation technologies. I would like to thank our business director for Abhishek Kumar for his work, to put some of the slides together and contribute in our discussions, just prepare for this session. Actually, it's a little bit irony for me to to present or to lead this topic. Originally from China. My belief in general is that kind of a mutual global kind of a trade usually generate peace in the world. But we do realize how important the battery field can be for a country. I'm a U.S. citizen right now, so we all care about this land and the safety of our lives and stuff like that. So yeah, so before I go even more, so I'd like to see, first of all, if we come to this session, can we, do we agree that U.S. already falling behind in the battery manufacturing field? If you agree, you may raise your hand. Okay, yeah. So, thank you. You can put down. Yeah, we can reach a consensus that this is something that is really reality, right? So, I think also the other question is, do we agree that U.S. have to have our own battery manufacturing here? If you raise your hand, I think it will also raise this consensus, right? So great. So let's see. Oops, sorry. Before I go further, oh, sorry about this. Ooh, it's getting funky. Let's see. Let me go back a little bit. Yeah. So also would like to see, where you're working at probably. If you are working in a gigafactory, or they're supporting a gigafactory, can you raise your hand? Not too many, right? So I cannot see. Oh, but yeah, I think it's relatively small number. Oh, okay, great, Sama, thank you. Yeah, and also if you're working in a battery startup or supporting a battery startup, I think okay, that's a majority. Okay, thank you. And if you are, let's see, investor in this kind of realm, can you raise your hand? Okay, there's that. Okay, Jason, thank you. Yeah. How about any policymakers? Okay, I didn't see any right now. Yeah, and also any government agencies, FBI, CIA. Okay, I'm just kidding. Okay, thank you. And of course, mostly or a national lab or like those. Okay, thank you so much. I think how we want to go is first I'll make an introduction of myself, and then following that, I'm going to guide certain kind of discussions, right? So first of all, we want to reach certain kind of, one, we want to be objective because we are all biased to some extent, but we try to be objective as possible. Two, we don't want to be extremely partisan or bashing any specific political figures on this, right? Three, we want to, let's see, if some of the topics we can quickly reach agreement, we spend less time on that. But if it's like a worth of a more discussion, we spend more time on that. Feel free to open your mic and jump in and contribute to the discussion. And in the end, the time after the guided one, feel free to come back and to do more discussion. How about that? Yeah. So let's see. Let's get to. Just a quick introduction of Ampcera. So our key technology is the all-climate, fast-charging, solid-state batteries. So the key is to overcome the adoption barriers, especially in the North American market, right? So we have the technologies to specifically address that. And also, the key technology for Ampcera, one is the material side, is making the critical material, is the solid state electrolyte, and then the other one is about, the battery kind of integration and those technologies about manufacturing and stuff. And our, business model included, we cover all these kind of different technology realms and, material supplies, cell integration, battery, cell kind of scaling up technologies and manufacturing, processing those technology as well. Yeah. So we have so far generated, more than 50 patents and 92 cigarettes in the related field. These are more details. We're open actually to kind of collaborate with academics, with the industry, with the partners for scaling up and stuff like that. So there's some more detailed ones. There's one specific thing I want to point it out is this, the dry electrode approach, which US may still have some leading edge on that, right? So we want to maybe dive a little bit down the road in our discussion. So with that, I would like to, let's see, encourage you to open your mic and maybe, let's see how many people we have right here. It just didn't show up here. Okay. So, okay, we have 40 some people, right? So here, right now, let's go maybe have, when we started our discussions, right? So feel free to open the mic and speak about your name and your affiliations, right? And talk about that. How about this? Yeah, so let's see. Let's go forward. First, we all agree that China already dominates pretty much 80% of the battery market, right? So let's see. And then the next question would be, sorry. We already agree that, but how the US fell behind the battery manufacturing field? Feel free to open your mic and then give your ideas on what happened and what factors contribute to this kind of a.
I think there's no infrastructure for commercialization manufacturing technology. You have the technology, but you don't have commercialization infrastructure. You lose it.
Infrastructure, right? Yeah.
I disagree.
Yeah.
I disagree with the question. I don't agree that U.S. has already fell behind. I don't know if the U.S. was ever in a leading position.
Okay.
Okay, so essentially, when we're talking about lithium-ion manufacturing, the United States was never a leading manufacturer of it. Predominantly, the specific vertical segments that were served by lithium-ion were electronics and things like cell phones. The U.S. never had a position in that. Right now, we're talking about electrical vehicles. That's a totally different story because the number of zeros in terms of production are completely different than they were for electronics, consumer electronics and those applications. So it went from Asia to Asia.
Okay.
US didn't fall behind. It didn't have the infrastructure to build those.
Yeah. So what's
one could say that we had the innovation edge, but we never converted that innovation edge into manufacturing.
I'm not sure we had an innovation edge.
Keep in mind, we have two, Nobel Prize winners in this field, right? Dr. Goodenough and, a lot of the original kind of ideas and the creations are from the U.S., right? Or, on the Japan, right? So
two men don't make up the U.S.
Pardon me?
Two men do not make up the U.S. We have plenty of PhD electrochemists in the United States of America. There's no lack of that.
Uh-huh. Anyone disagree or agree with Eric? Eric, where are you from?
Comment on that. This is Kevin Rose. So I work in the space around 20 years for electrification. So I think maybe it's a semantics argument. So I hear what Eric is saying about falling behind or not having even started, so somewhat. But I guess I would characterize it as falling behind, and so I raised my hand. I think that he did make a good point, though, in terms of the early stages of the battery, where a lot of that was supporting consumer electronics and other areas that we did not really invest heavily, and we didn't get involved in that industry as much. Research is certainly there, but in terms of the manufacturing, and I think part of that was driven by the raw materials, some of that, and the domestic sourcing of that is simply different. And the current chemistries that, NMC and others would tend to be towards some of those materials that are not as prevalent here. So I think that I do feel that it's a slightly behind, and I think that that's a combination of resources, but also due to domestic investment and interest in that area until it became more of a matter of national security, which I think we're seeing more now.
I would say I'm deeply involved in helping American battery companies get going in the U.S. That's my primary interest. So I'm always taking a look at this very closely as to what the bottlenecks are, say. I also get to walk around factories in Asia and Japan and other places, so I have a little bit of a sense of what it looks like on the inside of the box. And I think the United States, we don't have a good backbench of men in their mid-40s say that we could pull into the market right now when we want to add 2 zeros to the productive capability within this one industry vertical. We just don't have that. The reason for that is we actually never developed it. It's not like they're just sitting there waiting to be hired on the bench. They aren't there. We can try to pull them out of adjacent industries, but then those industries aren't saying, oh, here, we have an extra 20% of our skilled employees. You take them. Just
Yeah,
isn't
that's a
happening.
great point. I think education is another one of those, right? In terms of training, and I went through my PhD in batteries, and as you have seen over in a lot of those Chinese plants, there's a lot of people with relevant skills working in that area. They've invested in that over time, right, and developed up that skill set and that labor market that can support those kind of operations. And it's not as prevalent as it is here yet. So, all key areas that I think need focus in order to really make us successful is aligning chemistries to domestic supplies that are non-FEOC compliant, and also making sure that we have the right talents and the right next generation of engineers and leaders and employees to help push that forward.
Yeah,
Next slide.
Jason.
Yeah, actually, I echo what Kevin said that I mean, Automat has been engaged in domestic electrolyte manufacturing development. We actually experienced during the whole experience, so we see that it's not just the one set of one segmentation, it's the whole supply chain issue. I mean, regarding raw material, regarding equipment, regarding, I mean, the talents, everything. I think that build up the whole supply chain is taking time and taking efforts and taking investment.
Yes. Anyone else want to?
I would add just a point that I feel like US having more stringent environmental protection rules definitely played a role. Like for years and years, we just outsourced the introduction of CO2 into like China and other Asian countries versus like US. And I would agree with Kevin. I did my PhD in the United States, and except one person, everyone else that I knew in graduate school was Asian, Middle Eastern, Indian. So I feel like somehow in the United States, there's not much appetite for having like super professional focused workforce. And then the cost, apparently, I worked with a couple of Chinese companies in the past, like automotive mostly. And every time we were trying to have an R&D office or like a pilot line, we decided, okay, this is way cheaper in China. Why should we do it in here? And the project was shut down before it was even started. So yeah, that was my spiel.
Yeah, and another factor that you have to take into account is that US-based manufacturers have become more and more short-term focused over the years. Over my industrial career, I saw this in spades, and that a lot of the emphasis was on how much money did we make last quarter, how much did we make last year, not how much are we going to make 10 years from now by implementing this new technology or getting into this new product line. So the rewards especially for the executives in the companies just simply aren't there in the US, whereas a company like, for example, Toyota has no problem investing in technologies that might not see the light of day for 20 years or more. Whereas if you go to GM or Ford and do the same thing, they'll throw you out the door.
It's like a corporate culture change, right?
Why? And where's the way out? So we can, everybody always says the thing about the Americans are quarterly focused. There's a structural reason for that. There's an advantage to it and a disadvantage, but what's the real why?
There's an old saying that you get the behavior that you reward. And if you look at especially how executives and large US corporations are rewarded, it's for, in a lot of cases, it's with stock options and bonuses and that sort of thing. And if you look at how stock pricing is affected, a lot of that is very short term. And so they tend to focus on doing things that will reward the company and improve the stock price in the short term. So they do things like when there's a downturn, they lay off lots of people. They buy back their own stock just simply to pump up the stock price so that investors will buy them. The big institutional investors will buy them. It will increase the price of their own stock that they're getting as part of their compensation. So a lot of it has to do with the reward system.
Okay, I agree with you. Now you said Toyota, so you took the strongest blue chip Japanese stock in the entire Japan as the example. How about the other 5 to 6 Japanese auto OEMs that aren't as good as Toyota permanently, even though they're Japanese and they work in exactly the same environment. Take a look at the battery manufacturers. See, everybody, top hand, which is the biggest Japanese manufacturer? Can you name 5 that aren't? Panasonic, say. What's the difference? They're all hiring from the same universities in Japan. They're all facing the same Nikkei stock exchange as their incentive in their industrial environment, but they're performing quite differently. Sony bailed out of batteries, folded up
Eric,
them out. Why?
can you answer some of, I see probably you already travel around and to see, these differences, right? Do you have any inputs on why? From your perspective, I'd like to hear your opinion on it.
Are you asking me, Eric?
Oh,
Or
yeah, Eric.
okay, so my point there was that when we pick out the A team of the Japanese, say, as the comparable, then we're going to get a very different comparison. And what I'm saying is within the same environment, we have a large variation in performance, even amongst, say, Japanese battery manufacturers. On the general sense, in the main, I'm in agreement with Tom. But the question is, if we agree with these things, those are structural. It's like the difference between swimming in salt water or fresh water. The fish don't know any different that are in it. So can we change fresh water to salt water? That's a significant industrial organization change. That's hard to make. So one of the big differences that I would note is that there's an implicit social contract in Japan that you stay with the company that you work in from out of college. If you have that stability in employment, geographically as well as with the firm, your behavior within that social organization is quite different and incented quite differently in terms of social control and individual performance than if you're in a market where every year you're looking at whether you'll still be at that firm in that same city in the United States of America, for example, the mercenary model of labor services. The behavior of individuals in those different markets differ significantly. And we can't say, well, it'd be nice without totally chucking industrial organization of one nation versus the other. So that's actually a very difficult thing to say, well, we'll just import the good ideas.
What do you mean is like a loyalty to the company or something like that, right? So, for example, like a Ford and GM, as we know, there's a lot of people rather with generations staying with that company, right? So, as Tom pointed out, sometimes, but I heard blames for MBA programs, things like that, right? So, what's your thoughts on that kind of thing? Same thing. A lot of people they're from grandparents start working at GM or Ford, and then they're still working on that. So, how do we resolve this kind of a cultural differences? Seems like there's a loyalty, that culture is aligned, but somehow in Japan they did that, but in the US somehow it didn't come up, right? So Vijay, you want to comment? Feel free to comment.
Yeah, I think I was at Intel 25 years. I was there till a few years ago, but 25 years ago I saw a dynamic which I think answers this question, and that was when Intel was top on the semiconductor supply chain or the that food chain. They deliberately pushed out manufacturing lower end technologies to Asia deliberately, and it was done at all levels. Like not only Intel but all companies did that at that time. 25 years ago, it was a government kind of a encouraged thing. Also, many factors were playing into that, but that was a push that was happening from the US. But there was also a pull happening from Asia, where they were pulling for these technologies over there, and sometimes it worked because there was enough push. Sometimes when there was not enough push, there were unfair practices because of which it got pulled in over there. So both combination of both the two things really accelerated that, and it was like a marriage made in heaven. That's what happened, and that's how we lost it.
Yeah. Anyone would, for this question, of course, our goal is to do a reflection And then later on, of course, based on the reflection, sometimes we can think about what can we do differently right now. So anything we can change, right? Things like that, or any mistakes, right? We can correct possibly, right? Going forward, right? So, or any suggestion we want to give for, you know, the policymakers or something to change the cultures or something. It's possible to do, right? So I want to move to the next one. Of course, I give some little bit, you know, I think to summarize a lot of you guys' opinion, right? So there's a lot of, you know, exodus of the manufacturing. It's not only on the battery itself, there's many other kind of supply chain hardwares, right? Equipments, manufacturing and other stuff, right? So get moved to other countries, right? So move to China, for example. And then also there is a loss of industrial expertise, right? So once those things move out, the people, the labor, the training, all stuff pretty much gone, right? So over generations, people change their jobs, and then or eventually some of the know-hows get lost, right? So the other, of course, the innovation transfer. We know there's sometimes, you know, there's IP stuff, you know, we know that's the IP, you know, always politicians are pointing fingers about people stealing, but what we learn is at a lot of times is that at the early years, US or Japanese companies, when they filed the patents, but they didn't file it, they didn't cover in China. So in the case, you know, legally, to be honest, that sometimes they can do it, right? So things like those, right? So that erodes some of the, like a first mover kind of advantage. We know that we talk about the, you know, the Nobel Prize, the initial kind of ideas and that come from in the U.S., but somehow these things when it get to the industrialized or getting you know, scaled and stuff, that thing moved to Asia. It's not only China, also Japan and Korea, in those countries too, right? So that's something. I just want to just summarize a little bit. We can move to the next topic, right? So China did invested a lot in you know, especially now we know that CATL and BYD, they're dominating the market. And in China, there's a lot of vertical integration. So the same street possibly can gather a lot of the supply chain stuff from one street, right? So that generated a lot of efficiency, that lower the cost, they're more competitive, and it become a good cycle in there, right? So, and also China built a very strong EV kind of a market there. So that now China already kind of surpassed the 50% of the EV kind of adoption, right? So in China, right? So that's something generates this kind of a cycle on that. So then, you know, other things of course we can talk about, you know, the innovation. It still seems like this is how we go, right? So we innovate here as startups, as universities and national labs. We generate a lot of IPs and stuff like that. Somehow when we go to the next level, as Sana mentioned earlier, right? So once we get to the pilot line, we see, it's much cheaper to do somewhere else. The pursuit of that kind of a labor cost or the, you know, this profit or driven stuff like that, right? So that also drive this thing to Asia, right? So another case study is, of course, how India would catch up, or, you know, India also, you know, import some of the technology to India and try to, you know, also play some roles in that kind of scaling process. So let's also study a little bit on how did China do it right. You know, I think the rise of everything pretty much started from the 2010-ish, right? So maybe we can do brainstorming. What's your understanding? How you see, based on your experience, what did China do it right at that time? And in the, you know, last 15 years, pretty much now become leader on a lot of the production. At least, you know, on the scale, on you know, those stuff, right? So feel free to jump in on your comment, what you see. What's your thoughts?
I think one thing they did very well is the government became very involved in pushing it. So they did a lot there that they put a lot of mandates on city centers and things for getting EVs in that areas. They also did a lot to support manufacturing in their different regions and incentivized a lot of you know, internal competition sort of between different regions to get grants and set up some of those manufacturing. So there was a lot of government support at the, I guess a lot of it, though, I think they targeted the right areas to get that industry up. In the United States, perhaps there's as you kind of alluded to or said there's a bit of a gap between the ideation and maybe the academic and taking that through to full manufacturing industrialization. And I don't think we have quite the same. There's some really great places that, like the battery lab at the University of Michigan, or the battery places like that can do some incubator and development things. But I think that China did a really good job with directing their investments to help bring up that industry and really aligning people there.
That's a good
Yeah, I would
point.
like to second Kevin. I feel like public-private partnership is something that China definitely is much more advanced compared to Silicon Valley. The United States, I run a venture studio for battery startups in San Francisco, and the culture is very different. I feel like we build billionaires versus the future. If you look at San Francisco, we are the hub of technology, but you don't see that in the city as much. Even the public transportation, like smart buildings, like we don't care as much, and the government doesn't step in. And I have seen from my personal experience that a lot of companies and Chinese companies who were on the verge of bankruptcy, the government saved them, but there were deals. You have to buy only Chinese batteries. You have to build your manufacturing line in here. I feel like, yeah, Kevin is absolutely right. There's a lot of government intervention that and public interest, and we don't have it versus like personal interest.
They cultivate the market, right? So that's what you mean, right?
Absolutely.
So, yeah. And also intervene if something, technology to rescue, or to come to rescue if it needed, right? So
Yes.
yeah, cool. Vijay, you want to
And
say
another thing you need to keep in mind is that at least in the U.S., we have an army of lobbyists who are out there working very hard to make sure that the status quo is maintained rather than having their clients be superseded by somebody else.
love it against this? So
Mhm.
There's some other key points. I would say that the Chinese companies were quite willing to come in at the low cost, low quality quadrant and move upstream. Japan also did this. PhDs coming out of their labs wanting to monetize what they've just come across in their PhD and basically hit the jackpot model of the United States industrial development isn't exactly the same pattern, shall we say. So what did the Chinese OEMs that we're looking at and saying that they were so smart do? They came in with a chemistry that was low performance, low cost. And that made sense for a market that needed low performance, low cost, small cars. That's not anything that an American would do, given the incentives of the United States market, or PhDs would naturally do. They want to come up with the most technology forward product which aligns with their PhD expertise, and have proven over and over again through the startups that they're incapable of actually bringing that to market, both financially and technologically.
get some of the technology maybe too academic, right?
Well, it's not
Lack of
proven.
or future support or the downstream support to lift them up to the certain level of scaling, right? That's in China. They did have a system maybe to support that, or maybe, but you think the U.S. is lacking of that, Eric? That's your point. Try to understand.
Yes. Well,
Okay. Yeah.
they were pragmatic and they were coming at it from the low end
Mhm.
instead of trying to come at it from the top end, and they
Yeah.
built out their ability. Something that it's a little bit hard to recognize is that in the first instance, China during that period of time was faced with huge inflows of labor from the provinces into the into the cities on the port sides, and that availability of labor meant that they were able and willing to throw labor at whatever they were doing.
Yeah. Deliver
And that has
advantage.
changed because as the Chinese labor has increased in cost, they've increasingly deployed capital to increase the productivity of those employees, or to reduce the number of employees necessary to build a kilowatt hour of batteries, say. What the result of that is that the Chinese manufacturers, even at the small scale of the manufacturers, not just the CATLs or the BYDs, are getting quite efficient at what they do, and they've moved up in the quality of their products as it's been necessary for them to do so.
Yeah.
These things have all worked together.
Yeah. Vijay, do you want to say
I think,
something? I know your hands.
yeah,
up for a while.
I think this was what we saw in about 2010 time frame in battery industry was part of a mega trend that had actually started 10 years earlier, even before the EVs actually had taken off.
Mhm.
So, and that was for an industrial trend where, like I said earlier, we were not interested in manufacturing and as a government policy kind of thing or whatever. They were outsourcing everything, first to Mexico and Canada, and then to China, and that was actually made worse because China made everything cheap, and it was very well orchestrated. So a Mountain Pass, this rare earths mine near Nevada, California border was the best rare earths producing mine in the world in 90s. And then certainly few years later, they became so expensive compared to what was going on in China that they had to be bankrupt. They became bankrupt. So that whole phenomenon was very well orchestrated by all kinds of different means. So not having the manufacturing infrastructure for the pilot lines and all that in US for batteries and all came much later. But that was part of the bigger mega trend that was happening in all industries at that time. So it cannot be seen in an isolation.
Raghav, is it right pronunciation? Yeah, I saw your hands up.
Yeah, I just have a couple of ideas. Idea number one is that I think in the recycling space, and I'm speaking from New Delhi, India, and I think both India and the United States as well as Europe, I think the recycling space can be taken up very strongly once the lithium-ion cell comes from China to India or any of these other locations, US or Europe. The second time in the recycling space, it should be in the same location and recycled indefinitely. That's point one. Point two is that the capital markets can innovate to find more money into these riskier industries. The subprime mortgages come to my mind, and that was a method of innovating financially. And so if we have more innovative financial sort of instruments, then the capital markets can be used to direct more capital into the battery industry. So these 2 points, recycling and capital market innovation. That's
more like you think government level or policy level should give those kind of investors more incentive to take the more risks on this, right? So that's your point, right? Right. Okay, yeah. So I think anyone else want to come in? Yeah. So I shared some of the reflection, or when I lived in China when I was young, right? So there's something I saw at the time too. When China just opened up, and then at the beginning definitely China was not leading, right? So with the open up policy to the world, and then China kind of invited the foreign kind of entities, right? Panasonic and all the, even BYD kind of, I think a lot of the technology might have originated from some of these kind of big guys, right? So, and then, learn from that. And then also after that, of course, all these things is possibly enter the government policies supporting and stuff like that, right? So as you guys already mentioned that, especially I think Kevin mentioned that, China especially very good at it is that to incentivize regional competitions, right? For example, the Guangdong or Shenzhen or Shanxi may have different local governments, but they compete, right? So and then they provide lands and all kind of policies and stuff, to incentivize this kind of a competition. Eventually, they drive the cost down, right? So and also that's really so concentrated, right? But I also see in the U.S., of course, we see in Illinois, New York, even in Arizona, we try to build this kind of a battery valley and stuff like that. We also start doing this, right? It's just maybe take time or something like those stuff, right? So and then to build that, right? In Arizona, we have Lucid, we have Sign, we have Ampcera. We also have LG, starting getting, inviting them in, and then also, American Battery Factory or something like that, right? So starting, these kind of projects start popping up, right? Other states, you guys probably know better. So the other thing is economy of scale. Once the thing reaches certain scale, then the price is really hard to beat. It happens, right? Other things, of course, the demand, global demand and domestic demand for this kind of consumer electronics, EVs, and now especially China created a lot of this kind of stations, right? Because China put a lot of on solar farms in Mongolia. There's a lot of a gigawatt kind of a big kind of solar farms, and also wind, and also a lot of the renewable energy stuff that requires a lot of the smart grid to tune to even out the peaks and stuff like that, that built a lot of stations that incentivize a lot of the demand there, that created that local kind of demand also globally, right? So it's shipped out to everywhere pretty much globally. That also kind of created that demand, right? So that demand goes, and then the manufacturing scales, and then it's become a good cycle on that. So, and also more like a more kind of, because they have a centralized government, so more the policy-wise very consistent over time, and then they constantly from the national level to invest, and also from the local government, province level to invest, right? I want to open up also at this moment to anything else that we think that possibly we can think of about this, right?
Eric here again. One point about your one of the most important things is how fast you can get to revenue if you're starting into something.
Yes.
And if you try to get into the market for EVs, which is what is driving this market in the United States, it has the longest period of incubation of any chemistry or cell design. It's going to take you 5 years to get into market, possibly. So that's extremely long. If you're talking about consumer electronics, the path to revenue is much shorter. Also, the volumes required for consumer electronics were significantly lower than the volumes implicit in the EV model. So the fact is the Chinese manufacturers were able to enter the market at a far lower scale because that's what the market required at that time, but the time to market was very fast. Time to revenue was very fast. It's the impossibility of trying to leapfrog that part, that growth of the market to get to the EV market is practically impossible for startups. The funding model and the technology and the manufacturing skill, all those things are totally missing to make that leap. That's an impossibility. So how do you, time to revenue, how do you shorten that so that you can actually be a viable manufacturer and grow? That's key. And that's always missing in these conversations.
Yeah, Eric, 100% agree with you. And that's why, for Ampcera, when we develop solid state batteries, right? So we immediately target the consumer electronics because it's, if we look back at the history of even the lithium ion, traditional lithium ion, right? It starts with camcorders from Sony, and, eventually when it's getting more mature, the Kokoni started putting these things into this car, to drive cars. And then, of course, Elon come in and take that technology and become Tesla, right? So there's a mature, definitely starting from the consumer electronics, stuff like that, right? So I think for the next generation batteries, stuff like that might need to also, go through this process. But I totally agree with you also on the for the EV stuff, definitely need a more like a stable kind of a capital investment, no matter it's from private sector or from like a government or other institutional kind of a support in order to survive or prosper, right?
However, I think Eric previously mentioned a really good point. I feel like we have the appetite to go from 0 to 100, while China goes from 1 to 10. We focus on research and development. They focus on deployment. Like if you look at the ratio of dominance of LFP to other chemistries in China and in US, you'll see the difference. It's like 10 times more in China. They took the LFP, they deployed it into all the school buses, public transportation. We just missed it because for us, LFP was not good enough. We focused on eVTOL, we focused on autonomous taxis. Like I love Waymo's. I always use them. But we missed the obvious of like, let's use the technology that already exists, deploy it, build the knowledge, build the experience. We just didn't do it.
Mm-hmm. Yeah. So yeah, so this is the thing, China not only in the battery field, repeat this kind of a story. So this is pretty much covers a lot of other fields, solar and EVs, even shipbuildings, right? Other kind of not chips start picking up and stuff. As the sanctions and stuff forced China actually to jump on a lot of those stuff. They start excelling on those stuff, right? So just want to give a big picture on what's happening right now on that and what the history used to be, right? So I think we want to talk about maybe briefly on the I think at the beginning when we did the survey we kind of quickly touched this a little bit, right? Why does USA have to have this kind of our own battery manufacturing capabilities? feel free to speak up on your understanding why we have to have that. Why just we don't only just buy, right? So cheap.
I think it's a fundamental technology it's really it's cornerstone to a lot of stuff. I mean, transportation is, of course, that's a huge market that we all want to grow, or I imagine we all want to do. But like you said, that's 0 to 100. I think you're right there. You know, the electronics data center support is going to be increasingly important. ESS and grid leveling, all these things are going to have that. And having, I mean, we've all seen, you know, the trade situations as they go. All that is critical for that. To be domestically sourced or to have some kind of supply there that's going to be available to us. And it extends beyond just the consumer side of things too. It also goes into military applications and a lot of devices that are then there that are really, you know, they're critical source of supplies. You know, you can't put a foreign entity of concerns BMS into you know, a system that's going to be in one of those things for security reasons. There's a lot of reasons that they do need to put that capability for battery manufacturing and the support equipment for it. So I forget who mentioned it, but very astutely, you know, foils for going into the you know, the current collectors, casings, just buying casings that are for cylindrical cells can be difficult to. So all the things that go into that supply chain also need to be established so that we can have some domestic security and shore up the industries that we want to put them in, right? Since it's an enabling technology. We want to create all kinds of things, but they're going to need energy supplies, and right now it's the best tech we have. So I think that's one of the key reasons we need to do it.
Anyone else? Any thoughts? One simple analogy is that during the pandemic, right? Of course, even as simple as masks, stuff like that, right? So supplies, when it's sometimes when they have a spike of demand, or you know, certain times, right? Or you know, like now tariffs, if importers or something somehow stopped somewhere, then it can create a certain kind of a shortage in a short time, and then you know, that's created some uncomfort situation, right, for you know, civil and also defense kind of applications as well, right? So yeah. So if I think anyone else wanna, of course I put up this kind of, you know, pretty much also reflects a lot of Kevin's points on how important this can be, right? So certain times, you know, that's especially, you know, to add to that, you know, of course the smart grid, right? So, and of course sometimes politically, you know, affected how we view these kind of renewable energy, solar and stuff like that, but still that's a hard to mind, right? So for example, in Texas, right, so that stability, that's, you know, there's a winter, I think everybody frozen up, right? So, and losing power and stuff like that is definitely not a good situation, right? So that create a lot of demand on that, right? So, and also now we saw a lot of the investment shifted to AI. But a lot of times people ignore that, maybe not paid enough attention to, is the thing on the back, is that data center, or we talk about it in the next generation when we you know, utilize AI, eventually need a hardware to implement AI, to let AI to serve us, right, physically in those stuff. And then robotics become very important now, especially on this year's CES when I go there. That's become really, really big thing right now, right? So in the future, we can imagine in the next, you know, 5-10 years, probably this thing is going to come, right? So, you know, China with its power, like with the robotics, you know, implementing, I bet USA, we want to do that. Elon, you know, already have a robotics company, and into, you know, he's talking about how many each one of us have one robots, but these robots would be powered by batteries. And then also powerful batteries, better batteries and stuff in order to function, right? So, so yeah, do you agree with this kind of a, you know, situation, right? Eventually, you know, assuming that in 10 years or 15 years, we're more and more rely on this robotics, for example, right? So, you know, imagine that we run out of batteries on that. So how our life will be, you know, impacted, right? Imagine today, if we take all your phone, for example, away, so how that would impact you. This probably will be similar in 15 years, how much we may rely on those robots, right? So the things like that. So can you imagine with that, right? So I think we agree that I think the US all need to have this battery manufacturing capabilities, right?
Oh yeah, I think one of the things is also worth mentioning is domestic manufacturing, the trade war that we are going through. If the manufacturing is going to come back to US, considering the climate climate crisis, the CO2 reduction commitment,
Mm.
we have to rely on renewable energy resources, and then we have to rely on batteries for all of that. So that's, I don't know if it feels like it's like a chicken and egg situation.
Yeah.
Also, on the other hand, we never know when the next war is going to happen, and it takes one missile to shut down a power plant. So we have to definitely rely on virtual power plants and distributed energy resources that, again, heavily relies on batteries. So sustainability, independence, resilience, reliability, all of that needs just batteries, rely on batteries.
Yeah. As a nation, of course, sometimes we see, or, you know, just for investors, kind of, you know, that field, right? So the, you know, the perspective, you know, we saw like recently there's some setback in EV demands and stuff in the US or in Europe, for example, but we need to eye in the longer term, right? So which one is the trend, right? Which one will be ultimately, you know, of course, temporarily, you know, both administrations apply this tariff to protect this market, to let it grow. But the thing is that must grow, right? If we don't grow, you just use that opportunity just to profit on it, but without taking actions, that could be a disaster eventually, right? When we open up to the world. So that's also, so yeah. Eric, you want to say something?
So yes, the question of national security is an important one, and the United States in the post-war period, to establish its national security deliberately as a matter of policy, grew former enemy countries, Germany, Japan, and others, and opened the United States economy to their exports so that they would be stable in their geographies. And that was to the national security advantage of the United States to do so.
Mm.
So bringing all of that back home to US of A on the name of national security is an interesting change in opinion. And it has been up until this point, up until about 6 months ago, the opinion of the United States is that to establish national security was to have good relationships with your trading partners as policy.
Yeah.
The United States is no longer willing to pay that price, say, of national security. And so it's basically negotiated with diminution of international stature, which is being worked out currently in policy. So it's not necessary to actually have your battery manufacturing capabilities in US of A, given all of Kevin's perfectly good points, if you can be assured of friendly relationships with, say, Canada north of the border, which doesn't have quite the same put it on a ship and ship it across the border constraints as putting it across the Pacific Ocean, say. So
Yeah.
those things need to be thought carefully when we say we must have it in-house, therefore. I give the example of Japan, which as a nation imports 60% of its calorie consumption of foods. So if shipping were to stop to Japan, they would not be able to feed their population. In that reality, that's the actual statistics. How would you imagine the Japanese polity take a look at food imports and security and the ability to feed their population? So when politicians in another country say they're unfair, they're ripping us off, they don't allow us to export our rice, say, to that country, you have to really wonder whether it's not a good understanding of how things work.
Right.
You have to put yourself in the shoes of that country, which it would not be able to feed its population without safe supply in trade.
Mhm. Yeah, so I agree. I think, you know, that's better at least to have that, you know, that here, right? So of course we're talking about alien countries in Europe, or, you know, but Europe doesn't have this, you know, of course we just heard about Northvolt's bankruptcy. It's disheartening. And, you know, of course Japan and Samsung, they already have, they have some capabilities, right? But we look at the general kind of a geographic kind of a geology kind of a thing, right? So, you know, China definitely dominated 80%, right? So what if something happens? Would Japan and Korea be able to supply this bigger market enough, right? So that's a thing, right? So we're in the short term for you, especially sometimes, right? So I think it's still necessary or to build some US kind of capabilities on this. I think we agree, right? So Now let's move to the next topic. Is that what are the key challenges that we're facing right now, considering the nowadays situation in the U.S.? Yeah, other people also feel free to join in and mention your name and your affiliation at the same time. Let us know you, so later on we can connect on LinkedIn or stuff like that. Yeah.
The key challenge is the United States is labor skill constrained.
Yeah.
The rest can be bought and built with capital if there's a positive net present value to the project.
So as the more of the economy sector more shifted to services, and then a lot of the training, especially like young generations, they don't like to take anything require higher demand of math, right? Does it create a problem, especially like this kind of an engineering job, right?
It's worse than that. If you take a look at it really is. And if you take a look at the incentive to a young man or woman coming out of an engineering faculty, say in 2000, and they take a look, if they had perfect view of what would happen to manufacturing or the battery industry, say, would they necessarily self-select into that into industry? Probably not. They've done what it's been described here. They basically go for their PhDs and hope for the big payout in that. Would anybody rationally have gone into manufacturing? Would their parents have recommended that they go into manufacturing if they look at the lifetime earnings payout? No. So it's a negative net present value project for students coming out of university to choose manufacturing when they have better alternatives. And the US has provided better alternatives for those students. And that is why we have a dearth of men and women who are skilled in their mid-careers right now to say, hey, I've been there, done that. I can do that for you now in batteries. It's simple.
Yeah. On one side, we see this kind of a thing, but on the other side, on the Rust Belt, those areas, we see a lot of people, they don't have a job, they have a lifestyle that's different, right? So, things like that, right? So, it's kind of a complicated story, right? So, of course, for a lot of the kids, they wanted to go to be doctor, attorney, things like that, right? So, specifically, of course, is any solution? When we talk about challenges, of course, at the same time, we want to mention any way we can possibly overcome that challenges, maybe, right?
I think that I certainly agree with Eric. There's an aspect that I don't think that's the only constraint. I think it's maybe, I wouldn't entirely agree that anything can just be bought. I mean, it's a matter of degrees, right? So I think the accessibility of those, the security of those in those resources and things that need to be put in place. I think there is, from experience, it's not impossible to set up battery manufacturing capabilities. There are people and there are locations that are very well suited for doing that. And there are states that have put in incentives to try to help educate this and drive it. I mean, we're seeing that now. It is slow going. So I guess the question is how quickly can we ramp it up, and how far do we want to go with it, and can we compete on a cost basis from for everybody along that supply chain? Cost is king in a lot of this. At the end of the day, what does it take to make, if I need a battery pack, I can't make a good business decision and say I'm going to pay 50% more for it because it's here. Tariffs and other things help drive that and change it. But it's important that we make sure that we have something that's going to be cost effective too. So that's where I think, in our terms of our direction from national labs and from universities, focusing on low cost alternatives, similar, I think, to what was said there regarding some of the focus on LFP. That we saw in China, and maybe some enhanced focus here on the opportunities in sodium ion, or for some of the stationary applications in LMFP and next generation things for continued here. It's an opportunity to jump on and try to be the innovators and then ramp up that supply. But I think it requires us to make sure that we have the supply chain, and we're looking all the way from from the basic mining aspects all the way through integration to applications. And just finally, I'd say Eric's absolutely right. It doesn't have to be all here, right? It's when we say domestic, doesn't mean it has to be behind American borders. I think it comes into a really nuanced discussion about how do we impact this and find the best solutions with our most strategic partners, and make sure this is something that benefits not only ourselves but everyone around us. And
yeah,
good points, Kevin.